Hey everyone, so in this video we're going to go over this last example here, and there are a few ways you can go about finding the simplified version of this expression, and so we'll go through two ways that we can simplify this expression. So remember that we always want to end up with one of the x variables, one of the y variables, one of the z variables, and then we want all the exponents to be positive. So right now we have, what color did I use for x? I used orange. So we have the x's all right here. We have the y's right here. Oh, we just have one y. One y right here. We now have z's, the variable z. And then we also have the constant term 2. So we somehow have to combine the x terms here in orange and the z terms so that there is only one variable z and x shown up in the expression. All right, so first way we could go about this. So first way is we can use the power of a product property and also power of a quotient property first. So we can use the power of a product plus quotient property first. So what we mean by that is we could first distribute this 4 to all the exponents. So remember that when we have this 4 outside of the parentheses, we have to multiply each of the exponents, existing exponents, by 4. So this will look like, and remember that if there is no exponent shown, that the assumed exponent is 1. So this will be 2 times 2 to the 1 times 4, x to the 3 times 4, y to the negative 4 times 4, z to the 1 times 4, over x to the negative 4 times 4, x squared, x to the 2 times 4, and z to the 5th times 4. All right, so multiplying all the exponents by 4, we have 2 to the 4, x to the 12th, y to the negative 16th, z to the 4th, x to the negative 16th, x to the 8th, and z to the 20th. All right, so now we are left with combining the x terms and the y terms, or not the y terms, the z terms. So we can do this by breaking it down into more steps. So I notice that there's 2 x variables in the denominator, so let's try combining those first. So we can do this by using the product rule. So when we have x to the negative 16 times x to the 8th power, when they're multiplying, we can add the exponents together. So this becomes equals 2 to the 4th, and 2 to the 4th power is 16. So we can simplify that. 16 times x to the 12th, y to the negative 16, z to the 4th, and x to the negative 16 plus 8, and z to the 20. So this becomes now we can use the quotient rule. So we have these x's, the z's, where we could use the quotient rule. So this was the product rule. And then here we can use the quotient rule. So when we're dividing z to the 4th by z to the 20th, we end up subtracting the variables. So this becomes 16 times x to the 12 minus negative 8, y to the negative 16th, and z to the 4 minus 20. And this is equivalent to 16, and this becomes a plus. 12 plus 8 is x to the 20th, y to the negative 16th, and z to the 4 minus 20, which is minus 16. And now the last rule is we just have to make all the exponents positive, and we can do that by using the negative exponent rule here. And so we can make this into a fraction by setting this over 1, and then just moving each of the terms that have a negative exponent into the denominator to make it positive. So here we have the y and the z that have a negative exponent, and so by moving this into these terms into the denominator, we will have positive exponents. So this becomes 16 times x to the 20th over y to the 16th times z to the 16th. All right, so that's one way you could go about approaching this problem, by first using the power of a product or quotient rule. So pretty much multiplying 4 by all the exponents in the expression in parentheses. Now, what you could also do is simplify the expression in parentheses first, and then use the power of a product quotient. So let's do that and check to see that we get the same answer at the end. So another way is reducing or simplifying the expression in parentheses first. And then using the power of a product and quotient rule. All right, so we can do that by using the product rule in the denominator for the x's, and then we can also use the quotient rule. So this becomes 2 to the x cubed, y to the negative 4th, we still have z, over, we're first going to do the product rule in the denominator. So this becomes x to the negative 4 plus 2 times z to the 5th. And this is all raised to the 4th power. And so this becomes 2 times x cubed times y to the negative 4th times z. over x to the negative 2 times z to the 5th. And then we apply the quotient rule. So this becomes 2 times x to the 3 minus negative 2, y to the negative 4, and z to the 1 minus 5. And this is just over 1. So this is equal to 2 times x to the 3 minus negative 2 becomes 5, y to the negative 4th power, and then z to the 1 minus 4, or 1 minus 5, which is negative 4. This is over 1, and then this is raised to the 4th power. So now we can multiply all the exponents by 4 by using the power of a product rule. So this becomes equals to 2 to the 4th power, to the 1 times 4. X to the 5th times 4. Y to the negative 4th times 4. Z to the negative 4 times 4 over 1 to the 1 times 4. And this is equal to 2 to the 4th power, x to the 20th power, y to the negative 16th power, and z to the negative 16th power over 1 to the 4th power, which is just equal to 1. 1 times 1 times 1 times 1 is 1. So then we have 16 x to the 20th, y to the negative 16th, z to the negative 16th over 1. And so in order to make these exponents positive, what we have to do is carry them into the denominator. So this goes into the denominator, and also the y term goes into the denominator. And in doing that, we make the exponents positive. So this becomes 16 times x to the 20th power over 1 times, so this just becomes y to the positive 16th and z to the positive 16th as well. So this is our solution. Let's check to make sure that it's the same as our first one. Yep. So there's a variety of ways on how you can approach these problems. You can start with the power of a product rule, or you can first simplify the expression in parentheses and then apply the power of a product rule. It's really up to you, and that's why it's cool to work with these problems and see how your other peers in class approach these as well. So I encourage you guys to work in groups for this assignment, and now you can go on to practicing this in the assignment in Canvas. Thank you all.